Hi, everybody. Welcome to Algebra 2. It's great to see you guys back, and we're looking forward to going over our Saxon Algebra 2. So those of you who have joined us, this is our third edition, Algebra 2, and today we'll be going over Algebra 2 Saxon lessons 112 through 115. So we're excited to have you guys back and review over these concepts. Now, in our last lessons, we started out with quadratic inequalities, but a week ago we did greater than symbols. So this week we're actually going into the quadratic inequalities with less than. So if you can open up your books and join me at home with your video, and we're on page 453 in our quadratic lessons. So remember how we talked about the symbol greater than meant or, and they were a disjunction. They went opposite directions. Kind of like magnets, we think of repelling each other. Well, the symbol less than means and. A silly way that I remember it is less than land, less than is and. So that helps me remember. Greater is or, and even in a silly way, I think of that greater or sounds like it might be some element I had to memorize on the element table, right? So it's not really. But, you know, sometimes if our mind can attach something silly, that helps learning take place. So greater or, they repel each other, and less means and they join each other, right? They go in the same direction. So that's just a way to remember our inequality symbols and how they graph and what they look like. So since we've already done our inequalities that are greater, we're going to jump right into our inequalities that are less. Now, one thing you'll remember when we're doing quadratic inequalities, we have to check our solutions. We have to make sure that they are accurate. So the same is true right now, that we have to check our solutions and make sure they're accurate. So I would encourage you to spend time reading page 453 and 454 just to review over how they solve two problems and just the reasoning that they took place as to which one they use. You'll remember when we did the symbol greater, we thought through they had to be or, and we also thought through if something is greater than 0, it has to be positive. So we knew positive times positive makes a positive. And we also knew negative times negative makes a positive. So that's why we had to solve those inequalities 2 times. Well, this time we're looking at less is 0. So we know that in order for something to be less than 0, it has to be negative, right? So how do I get a negative? Well, I know that in order to get a negative solution, then I know that I have to have one positive and one negative. So that's why I have to solve both of these twice to see which one is true. And they'll be true. Last time when we did the inequality symbol with greater, we got one answer from one side and one from the other. That was a truth statement. This time, one side will not be true and the other side will. And so we'll get those so that they join. So a little bit of similarities and a little bit of differences. So I hope that that helps you all at home know how to solve these. All right, so if you would turn with me to page 454, we're going to practice together. And in our practice, we have 2 practice problems for lesson 112, and we're going to solve those together. So I'm going to move my camera angle there just so that we can practice together these 2. So I apologize about that. I did not realize I still had my phone on, so I turned that on silent. All right, so let's take a look at practice set 112, and we're looking at our practice problems together. All right, so the first practice problem that it gives us, I'm going to slide it over this way so you can see me as I work them out with you at home. All right. So the first practice problem it gives is it says solve each inequality and graph each solution on a number line. So we want to make sure not only that we're solving it, but we're also graphing it. All right. So we're on, again, lesson 112. lesson 112, and this is A that we're doing together. Now it says x plus 4, and it also tells us x minus 1, and it tells us that that is greater than 0. And don't forget the domain. The domain is the x values, and it tells us that the domain are all reals. So we understand that that can be decimals, it can be fractions, any of those things. So I know that as I solve these, it can include those fractions and decimals, so I can just write it on a number line. Remember, last week we had some that were only integers, so we had to put the dots at those places. So that's why it's important. I'm going to shift this just a little bit, so excuse me while I block the camera for a moment, and I hope that that helps a little bit. I apologize. You guys are my first one today. All right. So how do I set this up? Well, remember that we said before they either had to both be positive or both negative when I was dealing with greater than. This time, because it's less, I know that I have to have one positive and one negative, or I also have to have over here one positive or one negative. All right? Or you could switch those and put negative positive since we did it over here, if that makes it easier for you to follow. Okay? So if I say x plus 4, because it's positive, right, then it's going to be greater than 0. It's positive. All right? But x minus 1 is going to be the negative, so it's going to be less than 0. So I'm going to solve both of these. So I'm going to subtract 4. So x is greater than negative 4. And then I'm solving the negative by adding 1. So x is less than positive 1. Now, let's look down here at our number line. I have 0, 1, 2, 3, 4. Remember that these are going to join each other. Negative 1, negative 2, negative 3, negative 4. So if x were greater than negative 4, but less than 1, those would join each other, wouldn't they? So far, this one looks correct, right? X is greater than negative 4, but it's less than 1. And I put an open dot, but that would not, or excuse me, I put a closed dot, and we know that that's not correct because it does not include it. So hopefully you guys were checking me at home and thinking, wait a minute, that can't be right. So be on the lookout for that. It has to be an open dot, not a closed dot, because it's not or equal to. So we want to be careful of that. Now let's check it on the other side. This time x plus 4 got to be positive. So this time let's put x minus 1 is positive, and that's going to be greater than 0. And the negative is going to be x plus 4 is less than 0. That will be the negative one. So let's add 1. So x is greater than 1, and x is less than negative 4. Now let's check that out. If x were less than negative 4, but greater than 1, look, it would go this way. It would have an open dot here and go this way, open dot here and go this way. That's not how less than works. Less than joins. So I know that this was not a truth statement, and it can't work together, because remember, if it's less than 0, it has to end up being one positive and one negative to make a negative. So my solution has to come from this side. So this is going to be the correct answer, because this cannot be true. All right, they don't join. All right, so that was practice letter A. Now let's do practice letter B. Practice letter B. I'm going to erase this because these do take up a little bit more space. When you're solving these at home, or you're using a little bit more notebook paper than normal, welcome to Algebra 2. I am thankful that as we dig deeper in Algebra 2, we get into a little bit more problems that make us have to write just a little bit more to solve. So that's good practice for you guys at home. We already did A, so now we're doing B. Now, letter B says x squared minus 3x minus 10 is less than, again, less than 0. And this time it told us our domain is integers. Aha, that was what we were just talking about a moment ago. So I can't just put the lines joining because it can't include fractions or decimals. So in that case, I'm going to have to put the dots as to each integer that it can be. Remember, that's a positive or a negative number, but it's not a fraction or a decimal because that's not an integer. Now, what looks different about practice B that we didn't have in practice A? Did you catch it? Practice A, they had already factored for us. Now, Algebra 2, they're counting on you to know how to factor this quickly. So do it with me at home. All right, I just brought down my less than symbol and 0. I know that my leading coefficient's positive, so, and there's nothing in common that I can take out, so I look at my last symbol first. My last symbol first tells me that they are different, and it also tells me that the greater will go to the negative. Now I'm going to break apart my x's since the leading coefficient's 1, and I'm going to think about the factors of 10. Since they're different, they subtract to make 3. So what factors of 10 subtract to make 3? Did you get it? 5 and 2. Very good. The 5 has to go with the negative, 2 has to go with the positive, because negative 5 plus 2 would make negative 3. So we got it, right? Now, remember that I have to have a positive and a negative, and I'm going to work it out over here. This time I'm going to write negative first and then positive so I can keep the same order. So maybe this won't confuse you quite as much, right? So the positive of this would be x plus 2. Since it's positive, it's going to be greater than 0. The negative x minus 5 will be less than 0, right? Now, I'm going to do the same order, but instead of this one being positive, it's going to be negative. So x plus 2 is less than 0, and x minus 5 is greater than 0. All right, so let's solve each of these. Subtract 2. X is greater than negative 2. Add 5. X is, oh, excuse me, I've switched my symbol. Be careful, I only switch my symbol if I'm multiplying or dividing by a negative. So x is less than 5. All right, I'm going to solve this side as well, then I'll graph everything to see what is the accurate solution. So I'm just doing the inverse operations here, so I don't want you to be confused about that. So x is less than negative 2, and x is greater than 5. I just did the inverse operations there and just followed them all out. Now, let's take a look at my number line. All right, I've got 0, and it goes all the way to 5, 1, 2, 3, 4, 5, and -1, -2, -3, -4. I'm going to let it go a little bit further, right? We'll put 6 over here just for understanding of which way we're going. Now remember, it's less than, so it should join. It's a conjunction, whereas the other ones we called were disjunctions, right? They did not join each other. So x is greater than -2, so that would go this direction, but less than 5. So that would, those two would join together, wouldn't they? So far, let's put a check there. X is less than -2. Well, wait a minute, that would go that direction. X is greater than 5 would go that direction. They're a disjunction. So this one's not correct, right? Because they have to join each other. So I know it has to go these two directions. Now, because they're less than, I want to put a circle at -2 and -5. It cannot be that, right? So -2 and -5 can't be solutions because it does not include the 2 points. So I can't just draw a line because fractions and decimals are not included in this. So what do? I just put dots on what the solutions could be. So those are the only possible solutions. -1, 0, 1, 2, 3, or 4. 5 cannot be included and -2 cannot be included because it's not or equal to. So that is the answer to practice B that I have on page 454, and that's lesson 112. So we've gone through our first lesson today. Lesson 112. Now we're moving on to lesson 113. And this is going to be a new topic for us in Algebra 2 because 112 was finishing up the inequalities that we had been working on. So today we're actually looking at logarithms. How are logarithms different from anything we've done before? Well, your book starts out by explaining the known and then attaching that to the unknown so that learning can take place. I love that about Saxon. They start off with what you have learned and then move on to attach that to the unknown, so it can help you to draw conclusions and understand a little bit better. Well, they start out with reminding you what your exponent rules are. So let's start out there. So if I have a number and your book uses 10, so they say if I have 10 squared times 10 to the 5th, your book is pointing out to you that if your base is the same, then if you're multiplying, remember exponents are like that long lost friend that's one step behind, right? So if I'm multiplying, the step before multiplication is addition. Since my bases are the same, I just add my exponents, right? Now the book also teaches you if you say 10 squared raised to the 5th power, then you're raising to a power, the step before would be multiply. So in this case, it's not 10 to the 7th, it would be 10 to the, I hope you got it right at home, 10 to the 10th, because 5 times 2 is 10, right? Because I'm doing exponents, I'm one step behind. So that's what the book is reminding us there. Now it also reminds us, what if I had 10 to the 5th over 10 squared? Well, in this case, I'm dividing. Well, division is the inverse of multiplication. The step before division would be subtraction. My bases are the same, so I simply say 5 minus 2, so my answer is 10 cubed, or 10 to the 3rd power, right? So they're just pointing out what, how do exponents work, and how do I follow those? So it's just a review of your rules for exponents, and that starts us off on page 455. Now it goes into, since we know these and we've worked with problems like these, let's step into the unknown, logarithms. Now logarithms, what's really neat, we practice with the base 10. Well, logarithms are to the base of 10. So when you're working with logarithms, you need to know that logarithms are to the base of 10, all right? Now, there is a button on your calculator. I do not, excuse me for stepping off camera, but I forgot to bring my my phone out with us. But I don't have my graphing calculator with me, but hopefully at home you guys have some kind of app. So I have an app that I have a graphing calculator on my phone. So if you don't have a graphing calculator handy, pull up your smartphone, or you can always download, you can actually go to a free website that has a graphing calculator there. So that's going to be a great help to you. But you actually have a button on your graphing calculator, or some of you might even have just a basic scientific calculator. It's going to have log, and that's the base 10. And you'll see the inverse button up above it is 10, because it's the base, 10 base to the power of x. And so they've written that there. Now they have a button below it, ln. Now that's natural log. So those two buttons are similar, and we're going to talk about those. So what is a logarithm? Well, a logarithm simply takes the base of 10. So one way that we can write it to kind of understand, and the reason we use logarithms is sometimes, especially if we have large numbers, kind of like scientific notation, how we use that so we can easily multiply and divide. Well, we know the rules of exponents is if they have the same base. So sometimes we might have a difficult algebra problem, but if we get them in terms of the same base, it can be easier to solve that problem. So I know at home you were listening and you heard, easier to solve problems. So we all love a good shortcut. So I wanted to put a good plug in that this is a great shortcut. So that makes learning logarithms all the more better, is to know a shortcut. So if I say, one way for us to remember this is think through 10 squared equals 100, right? Because the base is so this is my base is 10, my exponent is 2, and the answer there is 100. Well, your book points this out to you, that 100 is the anti-logarithm, the inverse of that logarithm, right? All right, so your book writes it this way: log to the base 10 of 100 equals 2. Now, take a moment to think through where those went. The base 10 became the base of my logarithm, right? the exponent 2 became my answer. And 100, the anti-logarithm, is here, right? So log of base 10 is 100. Now, when it's not written, if they just give you the word log and there is no base written, it's an understood 10 because that's the standard logarithm. Now, sometimes they actually will give you logarithms that don't have the base of 10, and then they'll specify log to the base 4 or whatever the number is. So if you just see the word log and no base is written, it's an understood 10. Just like in English class, when your teacher looks at you and says, shut the door. Who shut the door? Well, it's understood who she's looking at, right? So just like we have understood things in English class, we have understood things in our math class as well. So when it's not written, it's understood base 10. All right. So your book goes through and explains to you how to use the buttons on your calculator. And I would encourage you, page 456 and 457 are wonderful tools. So sometimes we look at a book and we think, oh, it's hard to follow a book, and I would just much rather a person just tell me about it. And I totally get that, but there are times when it's important to read what they're trying to explain to us. So I do want to point out to you guys that it would be great, excuse me, my cat is running for my dog, so you just caught her tail. That's Ruby. She's a little bit shy, but she's watching from a distance. All right, so logarithms are something that it is very important that you understand how to use your calculator, and that will come in handy as we go forward in the coming lessons, both this year and in upper math classes that you'll have, advanced math, calculus, all those things. So learning your logarithms and how to use that is very important. Now your book goes through and shows you how to rewrite and how to solve those. So I would encourage you, even page 456, 457, and 458 have multiple practice problems. There are 5 practice problems that I would encourage you to look at and to go over, because we don't have time on this video to watch all of those. But I would like you to be encouraged to practice those at home. All right, so let's take a few moments and look at our practice problems. There are 5 practice problems that we have in our textbook, page 458. And again, this is lesson 113. So how do I do logarithms and how do I set these up? Again, you need a type of graphing calculator. So I want to encourage you to grab your graphing calculator or scientific calculator, any of those things to practice what we're about to go over. Okay, now I'm having a hard time resetting my window on mine. This is a new app that I just got, so I hope you guys at home have been able to practice with a calculator, at least a graphing calculator or an app, maybe even on your computer. So that would be great. Okay, so let's take a look at lesson 113, and the first question, it says find x, and I'm going to read what the book says so we can remember how we're solving these. Remember that if we know the base, there are only 2 other numbers. One number is the logarithm, and the other number is the anti-logarithm. Thus, we will always use the log or ln key, or the inverse log or the inverse ln key. So your book is reminding you that you have the log button and then the natural log button. So you're either using one of those buttons or you're using, the book says inverse. Some older calculators use an inverse and some have a second button. So you'll push second log or second ln for natural log. And natural log is denoted, so where you see log written this way, natural log is written ln, or the base of it is e. And that number for the natural logarithm All right, sorry about that. I think we had a little bit of Wi-Fi connection issue, so it muted me. So anyway, so natural logarithm, your book showed you what that number is. So it also even gave you an example on page 457, and it had you press the number 1 and then do inverse log to see the inverse of the natural log, and it gave you the number. So that is what the base of the natural log is. E has the value 2.718, and it keeps going there. So your book shows you how to set that up. So again, using your calculator, you'll find that. All right, so practice A says that we have x equals ln 0.0052. Now, this is the natural log. So how do I solve this? So practice A, if I know that the natural log is 0.0052, then I plug that into my graphing calculator, and I use the inverse of the natural log to solve that, right? So I end up with the answer that x equals, and again, you're just plugging this into your calculator, and you're either using the natural log or the second natural log button, right? So that's how we're solving these. So it equals negative 5.26. All right, so that's practice letter A. So logarithms can be something that cause us to think a little bit, but you can see they're actually pretty easy to solve. And the more practice that you have just thinking through what the base is and what the number and how our exponent rules work, when you practice those, that will make this a little bit more easy to navigate through your logarithms. Now let's look at B. B says e raised to the x equals 51.4. So I know e raised to some power equals 51.4, right? So on this one, I'm just using the natural log, right? And I'm just typing this in to find out what x is. So natural log in this gave me my answer. Now this time I'm looking at e raised to the x. So I'm having to do the inverse of the natural logarithm. So on my calculator, I'm actually going to type in the inverse of that. So your book reminds you, how do I write all that? Well, it's just the natural logarithm of e to the x equals the natural logarithm of 51.4. So I'm going to fix that parentheses there. So if I know the natural logarithm of that, how do I solve it? Well, I end up realizing that e has to be raised to what power? So in the end, x equals 3.94. How do I get that? I'm just using my natural logarithm button, and this time it's the inverse, right? So I'm solving practice B. All right, let's look at practice C. Practice C. All right, I'm going to erase some here so that I can see that part on the board. My board's filling up, excuse me, bad grammar there, huh? All right, so letter C, the natural log of x equals negative 4.16. All right, so I'm looking for the natural logarithm of what number equals negative 4.16, right? So I'm solving that on letter C. So I'm gonna use the inverse logarithm of x equals e raised to the ln of x. So I'm solving that. So I know that I'm looking for e raised to the negative 4.16, all right? So what does it end up? So I know my answer is e is 0.0156, all right? How am I coming up with that? Again, I'm just typing that into my calculator. So when I understand on letter C that my natural log of x equals negative 4.16, right? Natural log of x. So that's how I'm solving it. E to this power, what is it? All right. So my answer for letter C. Letter D. D says the log, this time I'm going to logarithms, not natural log. Now when it writes log, of x, I know that that's understood base 10 of x equals, this time it's the same number as in practice C. So practice C, it had natural log was this. This time I've got the logarithm. So I'm not looking at natural log, I'm looking at the log to base 10. How do I know it's base 10? Because it's understood base 10 when they don't specify. All right, so I know that I'm looking for the inverse log, right? So I know that when I write logarithms, it's to the base of 10, right? So I say 10, and I know it's to the log of x equals, both of these are to the base 10, right? So I'm looking at that equals the base 10 of negative 4.16. Both of my bases are the same. So when my bases are the same, I just set them equal to each other, right? So log of x equals negative 4.16. All right, so how do I solve that? Well, I know that this equals 6.92, and it's negative. So because the negative, right? 10 raised to the negative 4.16. So it ends up being, oh, I'm sorry, it's not negative. I don't know where I came with that. Negative does not give me a negative value, friends. The negative means its position. So remember that would be in the denominator, right? So my answer when I plug that into my calculator, so I've got 10 raised to the negative 4.16, right? And I used the inverse log, and I found out that the inverse log of negative 4.16 is 6.92 times 10 to the negative fifth, because it would have flipped it down into the denominator. So it would have been a very, very small decimal, but your calculator will probably rewrite it in this format since it's such a small number. So it would end up being 0.0000, there'd be 4 zeros, right? Because that would be 5 places it moved over, 4 zeros. All right, so we just rewrote it in scientific notation since it's a very small number. So that is letter D. And the last one, letter E. Use the natural log key to express each number as a power, then use the rules of exponents to find the answers. So how do I rewrite these? So your book has two numbers in the numerator, and then a large, actually it's very small, scientific notation number in the denominator. So how do I solve these? Well, your book takes those numbers and rewrites them in the natural logarithms. So let's do that. Now there is a practice problem that's like this. So again, I would encourage you, anything that's new is unknown. And you know, even when we were young, anything that was new, we kicked out and said, it's new. I'm not sure about anything that's new. But remember, the more that you practice with it, the more you use your calculator and practice with those natural log and log buttons, the more you'll understand inverse or second. When your book uses INV, inverse, most of you at home, your graphing calculators are going to have a second. So the more that you practice with that, the better. So your book has 0.00, let me see how many O's, 1, 2, 3, 6, 1, 2, and that is multiplied by 576, and then that is over 0.0512 times 10 to the negative 14. Whew, that's a very small number, isn't it? Now the book asks us to rewrite that in the form of a natural logarithm. So what would that look like? Well, it would just be the natural log of 0.000612 times the natural log of 576 over the natural log of 0.0512 times 10 to the negative 14th. So I've used the natural log on each of those. Now, I know that if I have the natural log, I'm using my calculator and plugging those in to find out what each of those is. So you at home, take this time to grab your calculator you need to make sure that you're familiar with plugging these in and getting these numbers. So the natural logarithm of this, what would it be? Well, it ends up as e. Remember that natural log is written like a cursive e, or you can write it a regular e to the negative 7.40 or 4, right? And then e to the 6.36. Again, you're plugging each of these into your calculators. You're getting the natural log of this. Now, this one is 0.0512 times 10 to the negative 14. That's going to be e to the negative 35.21. Now, because all my bases are the same, remember up here, I would just add these, right? So I would say e, my bases is all the same. I would say negative 7.4 plus 6.36. Now, it's minus a minus, so be careful of that because you're dividing. Remember we said before, division, the step before is subtraction. Well, it's minus a minus, so it's going to be plus 35.21. And I'm sorry, I ran out of room right there. So 35.21. I had to put the 0.21 right below it. All right. Now, all you have to do is add those together, grab your calculator and do that. So it's e raised to the 34.17. All right. So, and I can plug that in and inverse, so it's much easier than having to figure all that out, just because I got it all in the same base of natural log. So what's my answer? 6.92 times 10 to the 14th, final answer. All right, so this was just another way to solve it. Instead of using the actual numbers, I can actually get them all in the same base. That's how logarithm and natural logarithm work. If the bases are the same. So we remember solving exponents a lot by remembering that rule. If my bases are the same, right? All right, so that's lesson 113. It's a bit unfamiliar because it's new, but just remember, the more that you do something, the more practice that you have with it, the more familiar it will be. Now, lesson 114, something we've talked about a little bit, and I would encourage you again to use that graphing calculator or use your graphing app on your computer, but you definitely need to take time to understand how it is to graph, especially shaded regions. Now, your book starts out by just taking something that's linear. Now, remember that, and let me just put a basic line up here. All right, so again, we're on lesson 114. We've done lessons 112, 113, and now we're on lesson 114. So lesson 114, all right? We were just using e's, so that looks like an e instead of a lesson, right? So lesson 114. Now, what if I said y equals 2x minus 1? Now, that's a linear equation. How do I know it? Because x and y are both to the first degree, right? Now, if I asked you to graph that, what would I graph first? Do you remember? Good. I always start with the last. The Bible says the last shall be first, so I start with the last. When y is by itself, y, what's my best friend in Algebra 1? Y equals mx plus b. So we carry that fact with us into Algebra 2, right? So we learned that in Algebra 1. So my y equals mx plus b. My b is my y-intercept. So here's my y-axis, and here is negative 1. So it crosses the y-axis at negative 1. Now, what's 2? 2 is my slope, right? M is my slope. So that means it goes up 2 over 1. I can do it again, up 2 over 1, or I can go down 2 and back 1. All right? So in this case, this is my line. Now, you learned that even in Algebra 1. Now, what if I asked you, instead of solving this, what if I said y is greater than 2x minus 1? Now, we covered this in Algebra 1 as well, so I hope that you remember this. So a greater than symbol, you can actually go on your graphing calculator, and remember how we highlight the equal sign and we change it, because greater than, if you have a graphing calculator, the triangle on top is greater, the triangle on bottom is less. So what you can do is your graphing calculator will then shade which region is true. Now, if you don't have a graphing calculator that you're using right now, one thing you can do is test a point. I love to test the point 0, 0, because as long as your line doesn't go through 0, 0. Now, since it does not go through 0, 0, I can test it. Is 0 greater than 2 times 0 minus 1? 2 times 0 is 0. So is 0 greater than -1? And when we hear 0, we think, well, 0 is not greater. In this case, I'd rather have nothing than owe someone something, right? So having nothing is better than owing someone a candy bar, right? So in this statement, it is true. So I know everything above this line is a solution. So that's how I kind of graphed it with my expo marker. But one thing I want to point out to you is because it's not or equal to, I should not have a solid line. It should be a dotted line. Now, when you plug it into your graphing calculator, you have to make sure that you're on the lookout for that, whether it's dotted or solid. If it was or equal to, then it would be a solid line, and it could include the line. But it's anything in this shaded region up until the line, but not including the line, since it's not or equal to. Now, your book actually shows you the graph of nonlinear inequalities. So what if I had a parabola? So we've already learned how to do linear inequalities. What about when they're nonlinear? Parabolas, circles, and your book goes on. We've done, we have graphed absolute values, the V shape, right? So there's all sorts of things that your book is showing you. How do you graph those inequalities? Well, remember, you can always test a point. So sometimes if you're taking a standardized test like an ACT or SAT, if they've given you the solutions, what you want to do is check a shaded region, just like I chose the point 0, 0 because the line didn't go through it. Check a point and see which statement it's true for, and then you'll know which region to shade. So that's definitely something you want to look for, all right? So your book goes through examples on page 460, 461, and the top of 462 of nonlinear inequalities. And remember, in inequality, when I'm graphing it, I've got to shade one side or another. So your book gives you a graph, and then it shows you two nonlinear, well, actually one of them is linear, but one of them is a circle, and it asks which region of the circle would be a solution to this inequality. So look on page 462, practice. There's only one. All right, so it gives me x squared plus y squared is greater than 9. Well, I know that that's a circle. Notice that it's not greater than or equal to, so they did a dotted circle. Your book did all of that for you, and you can plug that into a graphing calculator to see that as well. Then it gave you y is greater than or equal to x. Well, I know that when y is greater than or equal to x, I know that on a graph, that means that it passes through the point 0, 0, right? That's the y-intercept is 0. And then my slope would be up 1 over 1, or down 1, back 1, right? Now, because it's or equal to, it is going to be a solid line, right? And then your book also shows you that you've got that circle there. And I apologize, I can't draw a perfect circle there, but you just let your mind imagine that and notice that it is dotted, because it's not or equal to, right? So your book asks you, is it region A, B, C, or D? Well, how do I do that? All right, so what I need to do is just test some points, right? And see where the statement is true. So I can't use 0, 0 because it's right there on that line, right? So what would I do? I would choose some other points. Like I might try, and the graph shows me that 2, 0 is right here, right? So I'm going to test this point 2, 0 and see if the statement is true. All right, so if x is 2, y is 0. So is 0 greater than or equal to 2? No. So I know that this region is not true because I just tested that point. Do you see that when you have an inequality, you can test it to see if it's true? All right, so I knew that it's not true there. I can choose another one for letter D How about 4, 0? 4, 0 is in the region D and not on any of the lines. So let's test it. All right, 4 is the X, 0 is the Y. Again, 0 is not greater than 4. So I know just by testing that point that region C or D is not included. Now, let's go up to region B. All right, so region B, let's find a point in there to test. How about -1, 0? -1, 0 is in this region, right? And it's not through the line. So -1, 0. All right, so -1 and 0. So 0 is greater than -1. This is true. All right, let's try another point out there. And let's try -4, 0. Oh, I put -40, sorry about that. So -4 and 0. So -4 would be out here. So this also is true. So I know so far A and B is true for this statement, but we have another equation, x squared plus y squared is greater than 9. So now I know that regions A and B satisfy this first equation. So how do I know which region is correct? I need to check this other. Because remember, it's a system of inequalities. And in order for it to be true, it has to be true for both. It's true, A and B are true for this equation, but let's see if it's true for this one. Let's go back to this one. -1 is my x. So -1 squared plus 0 squared is greater than 9. -1 squared would become +1. 1 plus 0 is 1. Is 1 greater than 9? No. So I know that region B is not true for the second equation. All right, in your book, it's actually listed first, so I apologize about that. Now, because I've eliminated everything else, process of elimination says it has to be A, but let's prove it just to be sure. So -4 is my x, so -4 squared. And notice that the negative is in parentheses, so I multiply by itself to make it positive. So it'd be plus 0 squared is greater than 9. So this would be 16 plus 0 is greater than 9, and it's true. A is the only region that is correct. How did I get that? Just by testing points, right? Now, on your graphing calculator, it's a lot easier because now they even make them colored. Graphing calculators are such a blessing. So they're colored and they'll show you where the colors overlap, and that's where it is. So it'll be much easier for you at home using your graphing calculator. Now, the last lesson that we're going to do is lesson 115. And 115 is something that is a little bit more tedious because there's a formula we need to know with compound interest. And sometimes it can start to get a little bit overwhelming, but remember, just follow that formula and make sure that you're using the formula for compound interest, and I promise it will make more sense as you follow that formula. Now, also, I want to point out to you that this is an extension of what we've just learned about logarithms. So just how they take that truth that we know and apply it to something that we might understand in the banking world of compound interest. So our last lesson today that we're covering is lesson 115. Lesson 115 on page 464, down at the bottom, it starts out lesson 115. So it goes through and reminds us about how we write exponents, just similar to what we've already learned about logarithms. So it shows us exponential functions. And something I think is really neat is exponential functions, they'll start out and you can see they're here and they'll just exponentially increase very, very quickly. So you can actually graph those on your graphing calculator to see how an exponential function goes up very, very quickly. Now, it also shows you when it's a negative number, how it can go downward very, very quickly. And that's on page 465, and it shows you those numbers and how the slope of it can be steeper or broader just based on what your base number is there. So it gives you just some exponential functions, and you're just practicing those there. All right, so page 466 shows a couple of examples that it's continuing to go through. Now, it's showing you two-step problems, and it's talking to you, and on page 466, it goes through if I know that there's bacteria in a dish and the number of bacteria increased exponentially. How can I figure out at what exponential rate that it increased by? So how would I solve that? So your book kind of solves through and gives you two practice problems there on page 466 and 467. So I would encourage you to go through those. It also shows you what buttons you would push on your calculator to know how to solve those. And just keep in mind what we said earlier about logarithms. If your book uses INV, some of you with newer calculators, that's going to be your second button. So be on the lookout for that. All right, and then the last part of 115 is part C, and that's talking about compound interest. And so it's talking to you about your principal, the amount you start with, and then if it has an exponential equation, it shows you that AT equals P, your principal, times E, we know that's the natural logarithm base, raised to the RT, your rate and your time. So that's where your formula comes in very handy. So you need to know that. So that's your initial amount, right? Your A to the base T equals P, your principal, times your base of E raised to RT. So I used to remember it's PERT, right? P times E raised to the RT, PERT. All right, kind of like your distance equals rate times time formula. If you can create a little acronym there, it can make things a lot easier for you to be able to solve. So I encourage you to look for little ways that you can solve those at home, right? All right, so the first practice problem it says is I've got 27 equals 10 raised to the x plus 5. Now, we've solved before basic algebra problems, but how about when I have my variable up in the exponent? How do I solve that? Well, my base is 10. Well, over here, 27 is not. So how do I solve those? I've got to get them both in terms of the same base to be able to solve those. So how do I do that? Well, I have to figure out what 27 would be. 10 to the what would be 27? Well, the base, so I'm going to do my inverse logarithm to find out what that would be. So it's 1.43 equals 10 to the x plus 5, right? So now if I set them and my bases are the same, since my bases are the same, then I can set my exponents equal to each other. 1.43 equals x plus 5. It's that easy to solve if I get them in terms of the same base. Then if the bases are the same, then my exponents have to equal each other. So in this case, all I'm going to do is solve for x. I'm going to subtract 5. So 5.00 minus 1.43. So my final answer, x is going to be negative 3.57. All right, so x equals negative 3.57 just by getting them in the same base, right? All right, next, practice B says, let me erase this. I'm just going to erase this practice A. All right, so we're on lesson 115, and we just did practice A, so now we're on practice B. Mary deposited $980, right? So that's her principal, $980. Mary deposited $980 at 7% interest compounded continuously. How much money did she have at the end of 9 years? And it gave us our formula there. All right, so I've got to make sure I plug everything in the right place. We already said my principal was $980, right? Well, we know the base is E, right? And we know that her rate, it told us her rate was 7%. So if it's 7%, don't forget that that's 0.07, because if I have a percent, that's in terms of 100, I take off the percent, move it over 2 places, 0.07. So E raised to the 0.07, and then how long did they tell us? 9 years. So let's rewrite that. 980 E, now I know 9 times 0.07, what would that be? 9 times 7 is 63. I have 2 decimal places, so it's going to be 0.63. So e raised to the 0.63. So I can actually plug that into my calculator, right? Because I'm looking for, in 9 years, what will it be, right? So I plug in e to the 0.63 and I get 1.88 times 980. So what is it? So my final answer equals, now your book actually says a to the 9 because it's in 9 years. What would Mary put this amount of money in? What would it be? Well, that would be amazing. Unfortunately, that's a higher rate than most banks nowadays would do, right? But wouldn't that be amazing? In 9 years, we took $980 and we more than doubled it, right? $1,842.40. Now, that would be amazing if banks did a 7%, right? Okay. Last one, letter C. All right. Letter C is another story problem. And I'm going to keep my equation up there. All right. And this time it says, let's read the story problem. The number of rabbits increased exponentially. At first, there were 400 rabbits. 3 years later, there were 1,600. How many rabbits would there be at the end of 10 years? So we're trying to figure out how much would be in 10 years, but we don't know the rate. So what I have to do is solve in terms of what I do know to try to figure out what that rate was. And then once I know the rate, then I can plug it in to solve for what it will be in 10 years. So again, this one's a two-step, and your book has an example of this, so make sure that you follow that. So it told us that we started out with 400 rabbits, right? And it said 400 rabbits, but at the end of 3 years, it was 1,600, right? And it gave us E, and we don't know what the rate is, so we're going to put K, but we do know in 3 years, 400 of them turned into this. I don't know what the rate is, so I have to solve it, right? So how do I do that? Well, I've got to get this in terms, but I can get rid of my numbers here. So I can divide by 400. So the zeros would cancel out and leave me with E to the 3K equals 4, right? Because 16 divided by 4 is 4. So I know that 4 equals the base E, which I know is the natural logarithm of 3 times K. Now, what I need to do is get 4 in terms of base E. So how do I do that? I plug that into my calculator and find out what the natural logarithm of 4 is. So 1.39 equals E to the 3K. So since my bases are the same, just like we've practiced before, my bases are the same. So I would just say 1.39 equals 3K. Because I've got my base the same, then I can easily solve that. Isn't that great how logarithms and natural logarithms can make problems easier if I get them in the same base? Divide both sides by 3, and I figured out what my constant is, or my rate in this case. So 1.39 divided by 3 is 0.46. So that is my constant there, my rate. So now I've got to go back and solve this. Remember, this is 2 parts. So they told me this all happened in 3 years. They want to know, hey, what's it going to be in 10 years? Well, again, in 10 years, we still started with 400. My base is E. I now know that my rate, we figured out, is 0.46. But this time, I'm multiplying it times 10 years instead of 3 years. So I'm going to solve that. So I want to know in 10 years, your book actually says a to the 10th equals 400 e to the, if I multiply by 10, I just move the decimal, it'd be 4.6, right? So I just grab my calculator. What is e to the 4.6? Well, I know it is 99.48. Again, use your calculator. So a to the 10th equals 400 times 99.48. So in 10 years, if I started out with 400 rabbits, please don't bring those home as a surprise gift to a parent, right? So if I start out with 400, if their rate of exponentially increasing after 10 years, How many rabbits would I have? Hold on to your hats, friends. A to the 10th after 10 years would be 39,792 rabbits. Whew, that's a lot of cages, right? So that's how exponential growth can work. So again, logarithms that we've talked about and how we can apply those. Well, I appreciate your time today, and thanks for joining me for Saxon Algebra 2, lessons 112 to 115. We'll see you next week.